Rebuttal: Evolution and the hormonal loop problem. Argument: Evolution cannot surpass the hormonal loop problem. The hormonal loop problem presents a significant challenge to evolutionary theory, one that is often overlooked in favor of more general discussions about natural selection and adaptation. Hormones are crucial for regulating a myriad of biological processes, including growth, metabolism, reproduction, and stress responses. The complexity of these systems arises from the precise timing and quantity of hormone release, which must be tightly regulated to maintain homeostasis. A critical issue with evolutionary explanations for these systems is that the regulatory loops involved are often irreducibly complex. For example, the hypothalamic-pituitary-adrenal (HPA) axis regulates stress responses. It involves a complex interplay between the hypothalamus, pituitary gland, and adrenal glands, each releasing specific hormones that trigger downstream effects. For this system to function, multiple components must be in place simultaneously. Hormone production: the glands must produce the correct hormones. Receptors: target tissues must have receptors specific to these hormones. Feedback mechanisms: there must be feedback loops that modulate the response based on hormone levels. In an evolutionary framework, these components would need to evolve gradually, but a partially evolved hormonal loop would likely offer no survival advantage or could be detrimental, as imbalanced hormone levels can lead to disease or death. Thus, a fully functional hormonal loop must have been in place from the start, which poses a problem for gradual evolutionary mechanisms. Intelligent design, ID, as a better explanation. Intelligent design, ID, provides a more plausible explanation for the origin of such complex regulatory systems. ID posits that these systems were purposefully designed with all necessary components in place, allowing them to function correctly from the beginning. This perspective aligns with observations in other fields outside biology, where complex systems are typically the result of intentional design rather than random processes. Evidence from outside biology observations, from fields such as engineering and computer science, support the ID perspective. For example, complex algorithms, software systems, and mechanical devices are always the result of intelligent planning and design. They require a fully functional set of components and instructions from the outset to perform their intended functions correctly. Partial or incomplete versions of these systems do not work, much like how a partially evolved hormonal loop would not suffice in a living organism. Addressing string theory and evolution's flaws. While the original critique conflates string theory with evolutionary biology, it is essential to recognize that both fields face challenges. String theory, for instance, is speculative and has yet to be empirically verified. It remains a theoretical framework with predictions that are currently beyond experimental reach. In contrast, evolution claims empirical support, yet it faces its own unresolved issues, like the hormonal loop problem. Evolutionary biologists acknowledge these gaps, although they often posit that future discoveries will bridge them. The reliance on this hope is reminiscent of the speculative nature of string theory, albeit with different contexts. Refuting the argument on endogenous retroviruses, ERVs. The claim that endogenous retroviruses, ERVs, are irrefutable proof of evolution and common descent is overstated. While ERVs are often cited as evidence of common ancestry due to their similar positions in the genomes of different species, this interpretation assumes that ERVs are merely the remnants of ancient viral infections. However, emerging research suggests alternative explanations. Functional roles. Recent studies have shown that many ERVs play essential roles in gene regulation, embryonic development, and immune response. This functional perspective suggests that ERVs could have been purposefully integrated into the genome, consistent with an ID perspective that allows for functional foresight in design. Convergent integration. Some evidence points to the possibility of convergent integration, where similar retroviral elements independently insert into similar locations in different species. This phenomenon challenges the straightforward common descent narrative and supports the idea that similar environmental pressures or genomic contexts could lead to similar integration events. Conclusion. While critics of intelligent design often dismiss it as pseudoscience, the hormonal loop problem and the complexity of regulatory systems provide a compelling case for reconsidering ID as a viable scientific hypothesis. Evolutionary theory, despite its wide acceptance, still faces significant explanatory challenges, especially concerning irreducibly complex systems like hormonal loops. Intelligent design offers a coherent framework that aligns with observations from biology and other fields, proposing that such systems are the product of purposeful design rather than random mutation and natural selection.